Hello everyone, this is a recording of RulerTech webinar, Resonance Search and Fatigue Test. So, what is a resonance? A vibration resonance occurs when equipment or a product is exposed to an external forced vibration occurring at one or more of its natural frequencies. Vibration resonances can cause catastrophic damage in poorly constructed objects such as bridges, airplanes, or buildings. Let me show you how you can run resonance search tracking well in ruler controller devices. Here you can see our current setup, which we are going to use in our tests. On the top of the shaker's table you can see a reference sensor, it's an accelerometer. On the left side of the beam you can see a response sensor, which is also an accelerometer. On the right side you can see a laser vibrometer, which will be used in fatigue tests. Now let's create resonance search test in our software. Our first step is to configure channels. We open Configuration tab and choose Channels. We will add another configuration and call it Resonance. On the first channel we have an accelerometer, its sensitivity is 10 mV per G and its type is IP. The second accelerometer has the same settings. On the third channel we have a laser vibrometer, its sensitivity is 15 mV per millimeter and its type is linear because it has an external power supply. We apply our settings and go to the main tab. Let's select Assign Test. Now we will create a new test. We will search for resonances in the range from 10 Hz to 40 Hz and the amplitude is 1 G. Now let's set up the test schedule. We will have only two commands here. The first one is run a profile and the second one is search for resonance. After that we go to the main tab, which is used for resonance search. First of all, we need to enter search parameters. Our first parameter is reference channel. We will select the first one. After that, let's select the response channel. It is the second one. After that, we need to select a resonance search method. We have three of them. The first one is transmissibility. After that, we have a Q factor. And then we have a first transmissibility derivative. Now I will tell you a bit more about these methods. Transmissibility is the relation of response channel amplitude to the reference channel amplitude. In our software we have a special graph for this method. All peaks you can see on the transmissibility graph are considered to be resonances. Another search method is the first transmissibility derivative. In that case, we calculate the derivative and find points where it changes its sign from plus to minus, so these points are considered to be resonances. And the third method of resonance search is Q factor. Q factor is the resonance characteristic which determines the sharpness of the resonance and its ability to cause damage. In this transmissibility versus time graph, we can see two peaks. However, if we select Q factor as the search method, only the second peak will be considered to be a resonance, because it has a higher Q factor value. Now let's continue in our software. We will select transmissibility as our resonance search method. After that, we can select a sorting parameter for our results. We can sort our resonances by frequency, Q factor, amplitude, or transmissibility. After that, we can set up our frequency resolution values. For example, if we have frequency resolution of 1 Hz and 2 resonances on 121 and 122 Hz, only the first one will be selected as a resonance. Let's set these values to 5 Hz and 5%. After that, we need to enter minimum transmissibility value. This value is considered to be the lowest level of resonance capture. After that, we go to tracking settings. Let's set emergency stop settings to 5 Hz and 5%. That means that during the test, if we have a frequency shift from, for example, resonance on 40 Hz to 35 Hz, our system will stop. You can also edit phase tracking options, but I will tell you about them a bit later. After that, we go to Limits tab and check our shaker. Here you can see our Tira 51110 shaker selected. After that, we go to Channels tab, select our configuration. It is called Resonance. Here you can see it. After that, we will disable the third and the fourth channel. Now we are ready to apply our settings. Let's save our test and call it Resonance. And now let's start our test. Now you can see that the system is starting up. We're using acceleration versus frequency graph. Now you can see that acceleration is starting to grow, and I think we're going to have a resonance on 20 Hz. Now you can see peak on the graph. It is considered to be a resonance. Let's wait our test to complete, and we'll see our final results. So now you can see our resonance search results. We have two resonance frequencies. It is 20 and 10 Hz, but only the second one will be selected as the resonance because the first one appeared during the test startup. Here in the table you can see the resonance frequency, its amplitude, its transmissibility value, its Q factor and its phase. Let's select the second resonance, and also we will allow resonance adjustment to get better results. After that we can change our take walk time into account option. It is used when you want to run your resonance duel for some time, for example 5 hours, 10 minutes or 30 seconds. You press this button and the test will run for the exact time. And now we can select our resonance tracking duel methods. We have two of them. We have a transmissibility tracking method and a phase tracking method. If you select transmissibility tracking method, it will use transmissibility for resonance duel tracking, and on the graph you will be able to see a transmissibility change. But if you select phase tracking option, you can use a special graph for it. It is called transmissibility versus phase and a special panel. Let's start with the regular transmissibility tracking. Now you can see that the system is starting up. Let's open transmissibility versus frequency graph, and here you can see that these points on the graph are moving from the lowest to the highest point of the frequency. So this is the first method of resonance tracking. Now let's stop our resonance duel and let's talk about phase tracking. We select our second resonance. Let's set up our time to 10 minutes and press phase tracking. After that we open the transmissibility versus phase graph. Here you can see a cursor which shows current phase. After that we open a phase tracking panel. Here you can see there are some options. Let's set our accuracy to 5% and gain to 1. The gain value shows the speed of phase change, and here you can enter the desired phase. For example, I need to reach minus 80 degree phase, so I enter this value, press apply, and you can see that our cursor is moving to the minus 80 degree phase point. Now let's try to reach minus 90 degree phase. As you may know, resonances usually have phase equal to 90 or minus 90 degree, so using phase tracking panel you can easily reach this value. I think at that point we can end with the regular sine resonance search and continue with fatigue test. The main difference between a fatigue test and a regular resonance search is that you don't need to place your sensor on your object during a fatigue test. If you search for resonances, for example, on a turbine blade, the accelerometer will influence its mass and also its resonance frequencies. So in that case we use a laser vibrometer. That's the main difference between fatigue and sine resonance search. Now we open a fatigue test. Let's create a new test. In our profile we will go from 15 Hz to 50 Hz and the amplitude is 0.5 G. The schedule settings in fatigue test will be similar to the previous test. We will run a profile and then select search for resonance command. After that we go to a resonance search tab. Let's set our first channel as a reference channel. Our laser vibrometer is connected with the third channel. After that we will select transmissibility as a search method and set frequency resolution to 5 Hz and 5%. As in the previous test, we're going to set emergency stop settings to 5 Hz and 5%. After that we go to limits tab and check our shaker. You can see that it's selected by default. Then we go to channels tab, choose our resonance configuration. In this test we won't use the second and the fourth channel, so we disable them. We entered all our settings, so we apply them. After that we save the test, let us call it fatigue. And now we are ready to start the test. Now you can see that the system is starting up, and I think we're going to have two resonances at 20 and 40 Hz. Here you can see our first resonance on 20 Hz. Now you can see that acceleration is growing and we are going to see another peak on the graph. Here you can see our main window for fatigue tests. There is a table with resonances, there are 4 of them. And in this test we are going to use the resonance at 21 Hz and 40 Hz. Here you can see that the Q factor is rather high and the other two resonances have Q factor of 0. Also, you can see some similar to regular resonance search options, for example, phase tracking or transmissibility tracking. And now let's start with regular transmissibility tracking. Let's select the third resonance and maintain resonance amplitude. Let's set it to 4 millimeters. You should know that is set in 0 peak. The system is starting up, so I will open transmissibility versus frequency graph. You can see some new lines on it, and here we see our resonance. Another useful feature is extended schedule. This way you can edit different levels for your test. For example, we will run our resonance at 4 millimeters for 30 seconds, at 6 millimeters for other 30 seconds, and for 8 millimeters for another 30 seconds. We're going to use displacement versus time graph, so we will be able to see our levels. Now you can see that we are running at 4 millimeters level. Here you can see the change of the displacement, and now we are running at 6 millimeters level. Now you can see that we moved to 8 millimeters level. After that, let's select phase tracking and set our amplitude to 5 millimeters. We will also select take walk time into account option. If you want to run your test, for example, for 10 hours, 5 minutes, 30 seconds, you can enter your time here. Let's open transmissibility versus phase graph and the phase tracking panel. Let's set our accuracy to 5% and gain to 1. Now let's try to reach a 90-degree phase. And now let's try to reach 160-degree phase and set our accuracy to 3%. Now let's select Startup outside the resonance function. It is used when you need to reach the resonance level smoothly. So we start running the test from a lower frequency. For example, I want to run my resonance from 37 Hz. In that case, I enter 3 Hz value. After that, you can change sweep rate and walk level before resonance. Let's set level to 60%. Let's open acceleration versus frequency graph, scale it, and here we see our start point at 37 Hz. You can see that we're smoothly moving to the value of the resonance, 40 Hz. When we enter nearby frequencies, you can see that the level is set to 100%. Another useful feature is multi-resonance. In that case, we select two resonances. Let's select the first one, set its amplitude to 1 mm. After that, we select our resonance at 40 Hz, set its amplitude to 4 mm. In that case, we're going to run these two resonance frequencies at the same time, and this function is shown only in fatigue test. Also, we need to disable startup outside the resonance function. Now let's open a spectrograph, and here you see two peaks at 21 Hz and 40 Hz. That are our multi-resonances. Multi-resonance is used when you test your object for its durability. For example, you need to break an object. In that case, you select multi-resonance function. and run it for some time. That's all I wanted to tell you about fatigue tests and resonance search, so let's move to the question section. The first question was whether it is possible to find resonances using random test. Yes, we can find resonances using random test, and I will show you it on example. Let's create a profile. Our start frequency is 10 Hz, the end frequency is 100 Hz, and our amplitude is set to 0.0001 level. During a random test, you can't use your laser vibrometer, so I need to change the configuration a little bit. After that, we check our shaker configuration and apply our settings. Let's start the test. Firstly, we need to open a spectrum ratio versus frequency graph and wait until the system starts up. And here on the graph you can see our two resonance frequencies, 20 Hz and 40 Hz. They are shown by peaks. But you should know that using random tests you can only find resonances, but you can't dwell them. The second question was about an issue that our user had. He couldn't complete a sign test due to a resonance which occurred while the profile was run. The system went to emergency stop. In that case, you should try to change your sweep rate. Also, you can enter another emergency stop settings or check the fixture on your shaker or maybe your cables. Here I see the third question, it's about our accelerometers. In this test we use two accelerometers, they have sensitivity of 10 millivolts per G and IEP type. Here I see another question about charge sensors. Yes, we can use charge sensors in our system. We have an embedded charge amplifier, so we don't need another external devices. Thank you for your attention. If you have any questions, don't hesitate to contact us.